In a previous video, I have shown that the Laplace transform of the Heaviside function is 1 over s, and that the Laplace transform of this exponential of minus at is 1 over s plus a. These are two very important results, but in practice, other Laplace transforms are needed from time to time. Fortunately for us, rather than having to find them from the definition, we may find them in tables where the calculations have already been done for us. We can consult these tables, which, together with the linearity property that we have seen, allow us to find most Laplace transforms and inverse Laplace transforms that we may need.
Suppose, for instance, that we want to know the Laplace transform of 2 times the exponential of minus 3t. Because of linearity, we know that this is 2 times the Laplace transform of this exponential. An inverse Laplace transform is walking backwards from the Laplace transform, that is to say, from a complex valued function of complex variable s to the real valued function of a real variable with which we began. So if we are asked the inverse Laplace transform of 4 divided by s plus 5, we know that this is the same as 4 times the inverse Laplace transform of 1 over s plus 5, and this one we know. Let us consider a more complicated case. We can rewrite this fraction as follows. Since the roots of the polynomial in the denominator are minus 3 and minus 10, we can carry out a partial fraction expansion. Of course, the product of these two polynomials will be this polynomial here, and this numerator here has to be equal to this. Since the coefficient that multiplies s is 1, as plus bs must be equal to 1 times s. Since the independent term here is 2, 10a plus 3b will have to be equal to 2. Now that I know this partial fraction expansion, I can write this inverse Laplace transform as follows. Thanks to the linearity of the Laplace transform, I find that this inverse Laplace transform is given by this.